Yeah, it's been a while. I'm gonna clear some of these cobwebs off here, dust off the old station, and let's get into some more Mastercam videos. So what I want to look at today is doing a simple part here, but making multiples of this part. So this question comes up quite a bit. How do I make more than one part, and how do I organize my tools when I'm doing multiple parts? So here we've got a simple part. It's basically a square. We've got a contour happening on side one, as well as a drill and a chamfer. And on side two, we're doing a little bit of a pocketing operation over here and another chamfer as well. So the thought process here is we want to do two of each operation. So I want to do two of this op one where we're machining the square and drilling the hole. And I want to do two pieces that are op twos, which is the bottom part here with the pockets and the chamfers. Okay, so a bunch of different ways we can go about doing this, and it's going to depend on how much control you want over the resulting G-code program. So let's first off start by talking about what it is we want to output to the machine. So likely scenario here is we've got a setup like this. We've got a double station vise. We've got two op ones in the front here, and then two op twos in the back. And what we would like to do is run each part off its own work offset. So this would be G54 on this piece here, 55 here, 56 for this first op 2, and 57 for the second op 2. Now, since we are using the same tool on different parts here, so this contour uses a 1/2 inch end mill, and this helical bore uses a 1/2 inch end mill as well, it would be best if we could keep that tool out, machine everything in the op 1 with that tool, and then machine everything in the op 2 with that tool, then do a tool change and maybe do the chamfer on both op 1s and chamfer on both op 2s. Then come in with a drill and drill our two holes. Okay, so that's what we would like to happen. That would be the most efficient use of our tool changes in the machine. But can we actually do that? So I'll switch back to our single instance of our part here. And again, having a look at our op 1s and our op 2s. And we've machined this as one component when we've machined it in the order that's best to machine one component. So we're machining the top side with tool changes, and we're machining the bottom side with tool changes. Should also point out that the planes used for the top operations and the bottom operations have offsets associated with them. So our top op 1 is using our top plane, and you can see here it's got an offset of 0 associated with that plane. So any toolpath that uses that plane will be output with G54. And then our bottom op 2, here we're using our plane bottom op 2, and you can see it as an offset of number 1. So any toolpaths using that plane will get output with a G55. So if I select both these operations and turn them into G-code, what we're going to get is we're going to get our first operation posted out here first on G54. So that's op number 1 with the 1/2 inch end mill. And we have op number 2, again on G54, that's the drill. Then we have our tool number 3, which is the chamfer mill running at G54. Next up is our second op 2, so G55 tool 1. And then finally down at the bottom here, we'll have another call for our chamfer mill on G55. So if we grab all this code, I'm going to grab all this and copy it and put it into Simco Edit. And we'll run a back plot on this just to show what this is going to result in. In Simco here, since we are using two work offsets, we can space them out just so we can see what that would look like on the machine. Because right now it looks like both pieces of code are running in the same place. So I'm going to work with my offset number 2. I'm just going to move it over 4 inches so we can see a difference between the two pieces of code. So this is what would happen on the machine. More than likely, you're going to have one piece, again, top up to machine op 1. Then you're going to flip it over, put it in the second station, and you'll machine the second side for op number 2. And there we can see that's what's happening with our one piece output. So now back in Mastercam, how do we go about making multiple pieces now with this source code? So as you might expect, we could just duplicate the solid, put it in different locations, and make more of the same toolpaths and put them onto those new pieces. We're going to explore that in a minute, but we'll first look at I wouldn't call it the lazy way, but we'll call it a quick way, which is it's quick and easy, but it might not be optimal. And that's by using this guy right here, this Toolpath Transform. So this can be found up in the Toolpath section over under the utilities. And I'm not going to relaunch a new one since I've already got one built out here. It's just going to repopulate with the values I have already. So I'll just open this up and we'll have a look at the settings that have been made in here. So in Toolpath Transformation here, we've got a bunch of different ways that we can duplicate toolpaths. We can translate it, which means we're just moving it somewhere else. We can rotate it. That is self-explanatory. We're rotating the toolpaths. or we can mirror it. Results may vary with mirroring, but so we're translating it over here. I guess we should define what the result is we want from these transforms. Is when we do this, we basically want to have, let's fast forward a little bit here, is we want a setup like this where we've got those 4 pieces. Okay, so 1, 2, 3, 4. So we want new work offsets for each piece. And obviously we want the origin still in the same place as our first piece. So if this piece here, the origin is the middle of the block, our second piece over here, the origin should be the middle of the block as well. I don't want to output code that's, you know, for this one, we're cutting this hole at 0, 0. I don't want to drill this hole at X 4 inches. Okay, so that wouldn't be ideal. We still want to drill that hole at X 0, but just under the new offset. So inside of here, what we're doing is that we're translating, and we're going to be using a tool plane method, and we're including the origin. So that will ensure that we get that new piece will have the same origin as the source piece. Now, not the same origin in the sense that it's using the exact same origin, but the location of the part relative to origin will be the same. And we're using different offsets, and we're controlling that use over here under our work offset numbering. So when we make a new instance of this top operation, the new instance is going to get a new work offset number. It's going to be one more than the last one that was used. Okay, so we'll get a G55 output for the second instance of this. And the origin of that new instance will be the same as the original. So it's still going to have 0, 0 at the middle of the block. So one thing that could be a little bit tricky here with these settings is, again, I've got top op1, and these are all coming out using the 0 offset, so G54s. And these ones right now are set to use G55. So if I duplicate this one over here, and I'm incrementing by 1 when I'm assigning work offsets, my second instance of op1 will get output as a G55, which conflicts right now with what these are being output as, or were being output as. And that's why we got this assign new. So even though this plane is set to G55, with the assign new, when this is duplicated, it's going to get its own new work offset. So we won't have a conflict there with the second op1 being G55 and the first op2 being G55. So it's all very confusing. We'll post this out into G-code here, and we'll have a look, and it'll all make sense. But inside of here, since we are using a tool plane translation, when we move these parts, so I've just got this set to a rectangular method, and I've just chosen spacing of 4 and 4. It's not physically moving the tool paths relative to origin. It's just moving them on screen so that I can see them in a different place. So I could leave them at 0 and not move them at all, and they would just stack on top of each other, and it wouldn't really be obvious that there's multiple instances of toolpaths happening. So I'm moving them here just for visual reference and knowing that I've got multiple instances of toolpaths. Okay, so let's have a look at this in our back plot here first. So as we drag through the timeline here, we're going to see the half-inch end mill working on op1. Then we're seeing the drill on op1. Then we're seeing the chamfers on op1. And then we're seeing op2 being done. So now we've got op2. And then we get the second instance of op1. So this is not ideal with the sorting right now. I'd like to do all of op1, then all of op2. So inside of our transform, we've got this operation switch over here between operation order and operation type. So let's have a look at the resulting difference here. And as we play through there, we're seeing half-inch end mill on the first instance of op1, then the second instance of op1, then the drill, then the chamfers, and then we'll switch over to op2. And it does each operation on both parts. So even during that back plot there, it wasn't totally ideal. We're seeing the half-inch end mill come out to do the op1, then it switched to the drill and the chamfer mill, then back to that half-inch end mill for the op2s. But let's have a look at this in our G-code and see what this looks like. So here's that G-code. I'm again just going to grab it all and throw it over into Simco. I'll just overwrite the current program. And since we have 4 offsets being output now, I'm going to adjust them to space them out. And I'm going to make our number 3 and the number 4 we placed there. Okay, so there we're seeing, again, that's kind of what that vise looked like. We've got the 2 op1s down front, the 2 op2s in back, and this is for 54, 55, 56, and 57. Now as we scrub through this one, we're going to see the limitation of using that toolpath transform. So there's the half-inch end mill on the first op1, second op1, tool changing over to the drill, chamfers, and then back to that 1/2 inch end mill for op 2, and then back to that chamfer mill for op 2. So we would like to keep that 1/2 inch end mill out for everything, but unfortunately, given our toolpath or an individual transform toolpath, we're not able to sort the toolpaths in that manner. So we can still use toolpath transforms. We're just going to have to use multiple instances of those transforms to control what tool is out and when. So here I've got our first transform in this new one. This is just doing the 1/2 inch end mill. It's only translating that one single operation for the op 1s. Then I'm doing the toolpath transforms for the 1/2 inch end mill that's being used on the op 2s. So when doing transforming in this matter, or translating this matter, we have to be aware of our work offset numbering. We have to be aware that the number we're starting at is correct based on the offset we're trying to perform these operations on. So with that, let's just have a look at the result here. I'll just post this out into G-code again, and again, put it straight into Simco. Okay, so here we are in Simco. I've got the new code pasted in, and let's just zoom in, scrub through this timeline, and see how this differs. So there's the 1/2 inch end mill on the first op 1, second op 1, first op 2, second op 2. Okay, then we're going to see that chamfer mill, both op 1s, both op 2s, and then that drill is going to come in all by itself at the very end. So the sorting here was much better. We've got the desired order of operations to keep our tool changes to a minimum. The only issue with this toolpath now is that I'm only seeing one piece of stock, and when I hop into verify, I'm not going to get full verification on what's going to happen on the machine especially when we're moving from one part to the next. We're confident that we're cutting this one part here by itself with no collisions, but it's when the tool moves between those work offsets that things can get a little bit dicey, and we're unaware of if we're going to see crashes. So this is where we get into needing to do that full part layout and completely machining everything so that we're confident we're getting crash-free toolpaths. So on this setup like this, if this was the way we were to go, let me just turn these toolpaths off. One issue we're going to have is that when that 1/2 inch end mill cuts around this second boss over here and it retracts up, if it wants to come down to the top of this part over here, if we don't retract up high enough, it could clip through this part as it approaches this pocket over here to cut over there. So that is one area of concern, and you may want to have that fully mapped out with toolpaths in order to catch a possible collision. So then with our toolpathing, we're going to have to take things one step further. So let's just get our red arrow down into our new setup down here. This is our multi-vice setup, or multi-station vice setup. And in this one, we're not going to use any transforms, although you could. We're simply using a plane at each individual location. So our vice part 1 op 1, our vice part 2 op 1. Notice the origin move. There's a part 2 op 2 part 1, and then op 2 part 2. Okay, and then there's a work offset numbering for them. So with this method, we are having to create multiple instances of the toolpath and change the plane for that toolpath. This is a bit extra work in that we do have to create multiple instances of each toolpath. And for example, if this contour, we decided we'd wanted to change the speeds and feeds on this operation, we now have to change the speeds and feeds in both operations. We're up here if we're using a transform of a toolpath. If I change the speeds and feeds of this contour, because I'm using the transform translate to make multiple instances of that toolpath, those resulting toolpaths would have those changes applied to it. But the benefit here is, again, we've got complete control over the order of operations, the way everything happens. So there's that 1/2 inch on the first, 1/2 inch on the second, straight over to that op number 2, and there's that possible concern. Again, that's if we have a dog leg rapid on this rapid right here, that's gonna it's likely going to crash, but we'll see that in verify if it is an issue. And let's just hop into verify right away and see if we do have any problems. Okay, so notice we do have stock for each part. Each part has its correct stock as well. So notice op 1 has been machined on these ones over here, so we will see an accurate representation of any instances. We've got our stop condition turned on to pause on collisions, and let's go ahead and play through. And much like we thought might happen, we are getting that collision happening between the transition of the op 1 over to the op 2. So the easy fix on this is we just need some higher clearances, but this, again, you wouldn't catch this if you just posted out the transforms on their own. So let's go ahead and fix this. This is the issue right here. And we're going to come into our linking. Just turn on some clearance. Just the easy fix for now. And this bore as well, we will enable clearance on that one as well. Okay, let's again double check to make sure that we've caught that collision. So no collision this time, and it looks like things are moving along the way we would expect them to. Okay, so now you can be confident when you post this out into G-code that you're going to get crash-free code, where you didn't have that little issue over there. And we can again post this out into G-code. And I'll bring this straight into Simco edit again. So there's the new program. Let's just rewind to the beginning. And we'll scrub through. So there's that higher return. Oh, so look at there's a difference there. So notice it hit the left op2 first instead of the right one. So I must have my offsets backwards inside of Mastercam. Okay, but that's all I wanted to point out about the multi-station vise. And another way that you can control the order of operations, and I guess another way to even go about cutting parts like this, is if we get into a situation where we've got pallets instead. So here we've got pallet with op1 and a pallet with our op2s. And on a setup like this, typically what will happen is the parts will be in a known location because we've got these fixtures made. These fixtures are going to accurately locate these parts. And we will know where these parts are. And as long as our models match in our CAD as to what the locations are in the real world, all we need to do is pick up a common location. So you might pick up maybe a dowel hole in the fixture itself, or maybe you pick up something off of the actual base of the pallet, whichever is easiest. But that's where you would set your work offset. And then inside of here, you can control multiple operations. So here we've got all these operations, all these different pieces just by using different chains. So the order of which they are cut is controlled by the order in which we've chained items. Also, when we want to change the speeds and feeds on this operation, it changes the speeds and feeds for all of these pieces, not just the one item. So this gives us lots of control over how they're cut, in which order, and in which tools, and in which station that we're working on. And again here with our verify, which is the most important thing here, we're able to fully simulate both pallets, as well as all of these 8 op2 stocks and all of these 8 op1 stocks. Let's hop into a machine verify here, and we can turn off that housing because it's kind of in the way. I can't see through it. Okay, so there's our 2 pallets on the machine, all of the individual stocks, and we can play through and make sure that we're not going to get any collisions. That's a good way to check there, but it's a little bit too fast for me to even see what was going on. So let's just rewind that with things slowed down a tad. Okay, so there's 2 pallets being run on the machine, and total control over which tool is brought out when and which work offset they're working on. So there's a bunch of different ways that we can go about cutting multiple parts. Those aren't the only ways. Those are just 3 examples of some methods for cutting multiple parts off of different offsets.